Hi everyone, I'll be sharing my screen right now. So in the last lecture, we discussed about the image enhancement techniques. There we discussed about what is the image negatives and we discussed about the contrast stretching. So in this video, we are just going to discuss about what is image restoration, how the degradation process going to happen. So go back to the previous slide. So this is the input that I took. So this is the input f of x comma y. But what's this problem in this particular image? This image has some noise. I have to remove that. So what is a removal of that? We will be saying as a discard or we'll be mentioning as a degrade or something. So the noise in the particular image that was represented this function, as well as I have to degrade this particular image. So this is the input I am going to take. The whatever the input I am going to take, that will be of 2D image. F represent the function f of x comma y. There is some noise is there. The noise represented by this function. So this noise. There is some quality of the image is not good. So for that, it was mentioned as a this function, noise function. So I'm going to degrade that particular function. I'm going to improve the clarity. So because there is some noise and there is some quality is not good, so I'm going to degrade that function. So degraded function will be represented by this h. So for that, the function will be represented as g of x comma y. And I'm going to improve the clarity of the image. So after improving the clarity of the image, I'll be getting this as an final input. Sorry, final output. So this is the input. There is some clarity of the image is not good. So I'm improving the clarity. So this is f of x comma y. The quality is not good. So I'm going to degrade that. So for degraded function, I'll be represented as g of x comma y. So final output will be this. So this will be represented as f power x comma y. So this is how the explanation going to happen. So if you take out this image negative, the formula is g of x comma y equal to t minus f of x comma y. So that is the formula that you have to remember initially. So this is a formula. So you have to remember initially. So this formula is mainly used for converting the original image into the image negative. But for this, you have to remember three things. So this is the input f of x comma y. So the quality is not good. So I'm going to degrade this function. For degraded the function, we'll be using a g of x comma y. So this will be the final output. For taking out the final output value will be f power x comma y. So next, we'll be moving into the image segmentation. So mainly for image segmentation, it is also a similar type of similar to the image segmentation, sorry, image restoration as well as the image enhancement. So we have to, what is the main goal of it is that mainly to change the representation of an image into something that is more meaningful and easier to analyze. We're taking out a particular image. The particular image is not understandable to us. So what is the main objective is that we have to take out the particular image and we have to convert the image into the uh, format that will be understood by everyone. That is known as the image segmentation. So image, I'm going to take out the image. I'm going to apply the region of the interest using the segmentation. So you know what is the region of interest, ROI. So which is the exact thing we need and which one we have to degrade. So you know the formula for the degraded function. We have to apply that and we have to use the segmentation. What is the segmentation? We have to convert into the format that can be understood by the everyone. So how that can be processed? That can be processed by using the machine learning algorithm. So finally, we'll be getting an output for it. So there are various segmentations that are available. First one is the threshold based segmentation. So you can look into the particular image. So this image quality is not good. So what you have to do is that we have to improve the quality of the image. For that, I'll be using the image enhancement technique. So what kind of that image we are going to use? We are going to use a binary image. So in the binary image, we'll be having only the black and whites. So zeros and ones. Only that language will be understood by the computers. So we have to apply the language that can be understood by the computers. The computers that understand the language is the machine language. So automatically this is the input image. So g of x comma y. So but the problem here is that so f of x comma y. This is the input. The quality is not good. So I'm going to apply the degraded function here. So because there is some noise, so I have to remove the noise. So automatically I have to degrade this particular image. For that, the function will be g of x comma y. So initially I'm going to take an input as f of x comma y. The quality is not good. I'm going to degrade that. So automatically that will be represented as g of x comma y. So this will be the final input f power x comma y. So this is the thing that I explained through the particular image. So you can look into this image. So this is the final output that you got. Okay. So here white is more than the black. So what you have to do is that always the pixel value will be ranging between 0 to 255. Got it? So the white region is more than the black region. So automatically what you have to do is that the pixel value that ranges between, ranges more than 59. I mean from 60 to 255. That will be for the white color. So if it is less than 60, that will be represented as a black. So 0 to 59 will be for black color and more than 59 will be the white color. So this is of the threshold based segmentation. Initially, the quality of the image is not good. I'm going to degrade that. I'm going to improve the quality of the image. Then I have to represent the pixel value for both the black and the white color. Next, we can move into the cluster-based segmentation. So we can take an example as the wireless sensor networks. So there are various nodes are there. So it will be very difficult to carry out the all the sensor nodes at the same point of the time. What you have to do is that we have to divide that into the multiple clusters. So take out that we have a 49 nodes here. So what you have to do is that we have to divide that group as a 7-7. So automatically we'll be having the 7 clusters. So 49 nodes will be assigned accordingly. But according to here, there are 24 nodes are there. So we have to take 4 clusters. So each cluster will be having the 6 nodes. So how the group will be divided based on the K means clustering. So automatically for cluster 1, 6 nodes will be available. Cluster 2, 6 nodes will be there. Cluster 3, 6 nodes will be there. And cluster 4, 6 nodes will be there. So for each cluster, we'll be electing a cluster head. After that, we'll be having cluster 1, cluster 2, cluster 3, and cluster 4. So what the cluster 1 will do is that it will be collecting the data from the remaining nodes. And what it will be doing is that it will be sending to cluster 2. And cluster 2 will be sending to cluster 4. So similarly, cluster 3 will be sending to cluster 4. So all the remaining clusters will be sending its data to the cluster 4. And finally, it will be sending to the base station. So this is how this operation going to happen. So why cluster 4 is going to send the data to the base station means because that is near to the base station. So this is how this operation will be happening in the networks. Similarly, if you take a what concept? If you take a biometrics concept, so we'll be having the various data sets. So what we'll be doing is that same clustering concept will be applied to this biometrics systems. And what you have to do is that we have to apply the data set. I mean, K means clustering algorithm again. And what the cluster 1 will be doing is that it will be collecting all the input from this data sets and it will be sending to the cluster 4 and that will be sending to the base station. So this is the operation. So initially, according to the network concept, so this will be represented as a sensor nodes. If you take a biometric, so this will be represented as a data set. The cluster 1 will be collecting all the data from the data set and it will be sending to the cluster 4. So cluster 4 will be collecting all the data of the data set and it will be sending to the base station. So this is all about the cluster-based segmentation. Finally, we can move into the pattern classification. So what is a pattern classification means? So initially, we'll be having the sensor. So sensor is the pre-processing, and then we'll be moving into the segmentation. What is segmentation? The main role of the segmentation is that to improve the quality of the image. And then what we'll be doing is that we'll be applying the minutiae algorithm for finger based, as well as if it is a face, we'll be using the Viola-Jones window detector. Okay. So for each and every trace, we'll be applying the certain algorithms, and accordingly the feature extraction will be made. And then we'll be moving into the classification. What is classification? So for example, if you are going to purchase a mobile phone, there is a various clarity of mobile phones will be there. There, which is best will be extracting that and will be getting it. So similarly, I'm having a mobile phone. So this is an iPhone 13. So advancement of more mobile phone has launched. iPhone 14 and iPhone 15 are launched. Now, if I'm going to the mobile shop, so which is the reason one? Reason one is the iPhone 16. Only that I'll be purchasing it. So that's what. This is the input, and I'm going to improve the quality of the image depending upon how the user can understand, and then depending upon which kind of the trait I'm going to use, I'm going to apply the extraction, and then classification. There will be a various classification will be there, and which one is best and which should be preferred according to the real world, that should be preferred. And finally the output will be done. The simple as that. Until this, the image degradation process will be done, and then the image quality will be improved. That is known as the post-processing, and according to that, the decision will be made. So this is the sensing, and then I'll be improving the quality of the image, and according to the which kind of the trait I'm going to use, I'll be improving, taking out accordingly. And then there will be a various classification in that which is the best will be preferred, and post-processing will be output, and according to that, the decision will be made. So classification, you can look into this. I'm going to the fish shop to purchase the fish. So there will be a salmon and sea bass. So in that, which is best, I'll be coming to the conclusion, and according to the post-processing will be done. So pre-processing is that input that I'm going to take. Feature extraction. Feature extraction means what kind of the trait I'm going to take, and according to that, the extraction will be made. So if it is a finger based technique I'm going to take, in that I'm going to apply the minutiae algorithm. So I'm going to go to the fish shop, that which is the best fish, I'm going to purchase it, and according to that, post processing will be coming, output, and according to that, the decision will be made. So in this video, we discussed deep about what is image segmentation. What is the image segmentation? We'll be converting the image into the format how the user can understand. In the next video, we'll be discussing about the fingerprint. Now I'll be stop sharing it.